Ever pop the hood of your car and wonder how all that controlled chaos, all those little explosions, turn into smooth, reliable power? Well, the secret is actually hidden in some pretty wild-looking graphs. So today, we're going to pull back the curtain and really understand the symphony of power happening inside your engine.
See, it's not just a flat, steady stream of energy, not at all. It's a pulse, a rhythm. So what does that power signature actually look like from 1 millisecond to the next?
It looks like this. Kinda crazy, right? A wild ride of peaks and valleys. Believe it or not, this single, jagged line tells the entire story of one cylinder firing, and we're about to learn exactly how to read it.
So here's the plan. First, we'll get familiar with this heartbeat. Then, we'll decode what those highs and lows actually mean. After that, we'll zoom out and see how all the cylinders work together in harmony, understand the rhythm of that power, and finally, get into why any of this really matters to you.
All right, let's start with that single heartbeat. Before we can really get the story this graph is telling us, we need to know the language it's written in, and that means understanding what these axes are all about.
So the up and down axis, the vertical one, that's torque. You can just think of that as the raw twisting force that eventually gets your wheels spinning. And the horizontal axis, that's the crank angle. It just tracks the rotation of the engine's main shaft in degrees, all the way from 0 to 720 for one full cycle. So what this graph is really showing us is how much twisting force is being made at every single instant of that cycle.
Okay, time to zoom in. Let's really decode what's going on here. What is causing these insane spikes and these deep dips?
And boom, there it is, that massive peak. This is the main event, folks, the power stroke. This is that split second after the spark plug ignites the fuel, slamming the piston down and creating this huge, useful burst of positive torque. This right here is the engine doing its real job.
And just how much of a punch are we talking about? Well, at its absolute peak, this one cylinder is kicking out about 920 units of torque. That is a serious amount of twisting force from one tiny little explosion.
But wait, what about all this action dipping below the zero line? That's called negative torque. It actually means the engine is using energy, not making it. And that biggest dip? That happens during the compression stroke. The engine has to work and work hard to squeeze that mix of air and fuel before it can even ignite it.
And we're not talking a small amount of effort either. The engine uses up around 320 units of torque just for that one compression stroke. So here's the key idea. An engine literally has to spend energy to make energy.
You see, a single cylinder is powerful, yeah, but it's also incredibly jerky. You get one big push and then a whole lot of coasting and effort. So how does an engine smooth all that out? Well, it adds more cylinders to the mix and turns those individual pulses into a beautiful harmony. Let's bring in the rest of the team. Check this out. On the left, we have cylinder 1, and on the right, cylinder 2. What's the first thing you notice? Their power strokes, those big spikes, are happening at completely different times. It's brilliant. While cylinder 1 is busy compressing, cylinder 2 is firing, and vice versa.
And no surprise, this pattern holds true when you bring in cylinders 3 and 4. They all have the exact same power signature, that same jagged line, but they're all intentionally out of sync. Each cylinder is timed to deliver its punch at a very specific, very unique moment.
Now, this isn't random, this is a carefully choreographed dance. This precise timing is what transforms those jerky, individual pulses into a smooth, continuous flow of power. Let's really look at how this rhythm is created. This table just lays it out, crystal clear. You can see the firing order. Cylinder 4 goes first, then 3, then 1, then 2. Each power stroke is spaced out almost perfectly across that full 720-degree cycle. This spacing is everything. It ensures that just as one cylinder is running out of steam, another one is just starting its power stroke.
Here's maybe the best way to think about it. A single-cylinder engine, it's like one person pedaling a bike. You get a strong push and then a lag. It's jerky. But a multi-cylinder engine, now that's like a team of rowers. Each one pulls their oar at the perfect moment, creating this smooth, continuous glide through the water. No wasted effort, just constant power.
Okay, so we've geeked out on the graphs, we've seen the rhythm, but why does any of this matter to you? Because you feel the result of this incredible engineering every single time you drive your car.
And that brings us to the biggest takeaway here, this whole idea of staggering the power strokes. This is the invisible genius that turns a bunch of separate, violent little pulses of energy into the smooth, continuous power we just take for granted. It's what gives you that feeling of effortless acceleration, all without shaking the car apart.
So the next time you get in a car and you press down on that accelerator, I want you to listen. Feel that smooth surge of power? You're not just feeling an engine. You're feeling that perfectly timed 4-part harmony, a hidden symphony of power, firing thousands of times a minute, right there under the hood.